Okay, this is the training for the Stack Data Center project, and it is being provided by Pacific Paleontology of Santa Cruz and Monterey. This is the data center then and now. A lot has changed since the last ice age, but there are clues to what used to exist here in the past. For individuals with sensory disabilities, this document is available in alternate formats. Please call or write to the email address at the end of the presentation. Santa Clara Valley is known to have scientifically significant and widespread intermittent Ice Age fossil discoveries. And if the Ice Age rock layers are found in the project site, although unlikely, they could be found near the surface and potentially contain the remains of Ice Age creatures. It's important to be aware that violation of the federal, state, and/or local regulations is punishable by civil and criminal felony and misdemeanor laws and penalties, including fines or imprisonment, that could result in revocation of project certification and halting of the work at the discretion of the appropriate agency. If suspected fossils are encountered during construction workers shall immediately halt construction within 50 feet of any potential fossil find and notify the supervisor, the project manager, and the project paleontologist, Wayne Thompson, at Pacific Paleontology, 831-535-8545, who shall evaluate its significance. Failure to report suspected fossils is a violation of federal, state, and/or local regulations and is punishable by civil and criminal felony and misdemeanor penalties, including fines and/or imprisonment. The California Public Resources Code states that no person shall knowingly or willfully excavate upon, remove, destroy, injure, or deface any prehistoric or vertebrate fossil site, including the fossilized footprints or any other paleontological feature situated on public lands, except with the express permission of the public agency having jurisdiction over those lands. Violation of this section is a misdemeanor. The main regulatory document for the project site, the data center project site, is the California Environmental Qualities Act, or CEQA, which governs prehistoric resources. The California CEQA Act explicitly affords protections for paleontological resources as outlined in Appendix G, Section 5C, which addresses the potential for adverse impacts to unique paleontological resources, fossil sites, or geological features. Under CEQA, the treatment of paleontological resources is usually conducted in accordance with guidance from the Society of Vertebrate Paleontology. CEQA's purpose is to provide a statewide policy of environmental protection and prevent significant avoidable damage to the environment, including paleontological resources, by requiring mitigation measures. Some of those mitigation measures include site staff paleontological sensitivity training, as presented here. The County of Santa Clara also has General Policy Plan CRC-49, which addresses cultural heritage resources, including paleontological resources, and states that those resources should be preserved, restored, and commemorated for their scientific, cultural, historic, and place values. The City of San Jose also has General Plan 2040, Goal ER10, relating to paleontology, which states that any resources should be preserved and conserved in order to promote greater sense of historic awareness and community identity. It also requires paleontological mitigation to be incorporated into the project design, and city, state, and federal laws are to be enforced. At all levels, there is an obligation for the project personnel to protect and preserve any scientifically and socially valuable paleontological resources. Violation of these laws presented above is subject to federal, state, and local felony and misdemeanor prosecution under the law. This slide shows where the project is located in the South Bay area. This is another slide showing a little bit closer up where the project is located in the Trade Zone Boulevard area. This is a drawing of the surface geological areas in the region of the project, and it shows major features on the city of Milpitas, Coyote Creek, the Guadalupe River, and the San Jose Airport. These color-coded geological features are different layers of rock on the surface. In the project area, the layer of rock is a floodplain deposit. It is very, very young at the end of the last ice age. This slide shows some of the major fossil finds in the South Bay area around the Stax Data Center project. All of these locations are locations that have been recorded in the University of California Museum of Paleontology and other areas, and are significant vertebrate fossil remains that we'll be discussing and showing pictures of in just a minute. But you can see where the Stack Data Center project is there. And here's the answer key for that last slide, showing that they're the youngest ice age rock layers in floodplain deposits. That means they were deposited in river floodplains, and the creatures that have been preserved there record what the last ice age used to look like in the South Bay. Here's a little bit closer up showing the project layers. All right, let's talk about some of the aspects of what the soil might look like. It might look like this, a fine-grained, dark, silty soil. It might also look like cobbles and gravel. These types of soils are prominent for preserving the remains of ancient Ice Age creatures in our area. This is the tusk of a mammoth that was skimmed by a bulldozer. This is what it's going to look like. It's not going to look all pretty. It's going to look smashed up and broken. Typically, when tusks, which are made of ivory, get nicked by a large earth-moving piece of equipment, they're very fragile. They break apart into pieces, and this is what they're going to look like. I'm going to show this slide as well as the previous one because these are this one and the next two are the most important slides of the entire presentation. This is another view showing fragments spread all about in a dark colored matrix in the background. And this is typically what the fossils in our area will present as. This is a piece of fossil bone close up, and it's the internal bone, and it looks, I'm showing this for identification purposes, so you're going to note that there are many marrow canals in the fragment, making it look eaten away as if by termites. And that's what the internal structure and color and texture of the bone looks like that you may see. This is something very significant, and again, I'll show this slide at the end. If something like this turns up during earth-moving activities, it is important to inform the site foreman, the project manager, and Pacific Paleontology at the phone number included at the end. All right, let's talk about some of the fossils that are potentially going to be found during earth-moving on the project site. The first one and most prominent probably are large mammoths. These mammoths are they're herd animals, and so where you find one bone, you typically find more. This is another picture of a tusk of a mammoth showing the internal enamel layers. And so if you see a ring shape like this, it is most probably a piece of a mammoth tusk. And these things are not normally hollow on the inside. This one is at the end of the tusk where it comes into the root canal there, but these are usually solid all the way through. This is a toe bone of a mammoth. It's about 6 inches, 7 inches long. It's very large, and this is what the toe of a mammoth looks like. Here's what mammoth teeth look like. Teeth are usually preserved far better than other things with the mammoth because they're very, very dense and hard. So a mammoth tooth has this shape, and those parallel ridges are used for grinding grass. It was a grazer. There's another view of the surface of the tooth in a fragment of a mammoth tooth. This is a large mammoth tooth as well, showing what it looks like from the side. This is a mammoth tooth from down near Castroville. These things can be up over 14 inches long and 12 inches deep. Just single tooth, and they can weigh 5 pounds. One tooth. Here's a mammoth humerus, and this is from the Caltrans 680 site. This is what it looks like. You'll recognize the spongy bone on the inside, on the right there. And then the other characteristic of this is the linear grains of bone, as well as the color, the mottled color of the bone. This is a mammoth skull that was found. This is in a plaster jacket. It's upside down. You can see the two teeth right here and the tusks here. And this is extremely rare to find the skull of the mammoth. Here's a mammoth leg bone showing the size next to a pair of glasses. This is just a small chunk of the actual leg bone, tibia, and the lower rear leg bone, and showing the potential color differences. So some of these bones are going to be light colored, depending on the sediment they're preserved in. Some are going to be dark, depending on the sediment that they're preserved in, if they're in gravels. The other creature that you're going to find out at some of these sites is called a mastodon. They're related to mammoths, somewhat shorter, stockier, and very different habitat and habit and anatomy. This is a mastodon skull upside down. Now look at the teeth. They're going to look a lot different than a mammoth. The skull in general is going to look very similar on the surface at first glance, but the teeth are very, very different. This is a close-up of a mastodon tooth. They have these cusps right here, and those cusps are used for grinding leaves. Mastodons preferred alder trees, and they lived near valleys. Now, when you have a valley that opens up into a grassland, you get both mammoth and mastodon. We do have some of those sites nearby, and that's a very rare event where you have those two giant herbivores preserved together, but it does occur because they did live in different habitats. Mastodons by the rivers where the alder trees were, and mammoths grazing in the grassland. Here's a mastodon graveyard found at a construction site in Hemet, California. Here's what a mastodon ankle bone looks like. We also have short-faced bears. This is a cast of the original, an exact duplicate. And just like any bear, these things were big and mean-looking. We also have bison. Most bisons, we're going to find bones and teeth. These are some of the teeth of a bison. We also have pronghorn antelope teeth. They're slightly different. If you study the anatomy of these, they're slightly different than the bison, somewhat smaller too. We also have primitive horses in the area. This is at the Facebook campus excavation, fairly large site where fossilized horses were found, and ribs and various limb bones and skulls and teeth and things like that. Here's some more horse bones, the long bones. These are called the cannon bones. These are the lower leg bones. Here's a horse jaw found at the Caltrans 680 site, very near the project data center site, the stack data center site. We also have, and this is one of my favorites, ground sloths. We have both the megalonyx here, this short 6-footer, and we have Mylodon, this one right here, another 6-footer. Most of the megatheriums and megalonyx or megatherium and are the big ones are down south, Southern California, La Brea tar pit type. We just have the small ones here, and they're very rare. So if you find a ground sloth bone, that's pretty important. Here's some ground sloth bones, wrist and ankle bones. All right, this is what a dig site looks like. If a fossil is found, or multiple fossils, this is what it would look like after it had been reported and after a little while of digging. Notice the soil there. Okay, I'm going to go over the soil types again. This is really important, so I'm going to repeat it. Dark, fine-grained soils. These are often lake or channel types of deposits where sediment is extremely fine-grained, slow water, things like that. We also have very prominently and very commonly gravels in our area, Ice Age gravels, and those gravels also produce mastodon, mammoth, and all the other creatures that I just showed you. This is what the bone looks like if it's hit by a tractor. It's not gonna look all pretty. It's gonna be broken up, fragmented, and yeah, just kind of busted up a little bit. And here's another picture showing what it looks like in contrast to some of the dark soil. This could have equally well been gravel. And again, this is an important slide. This shows what the internal structure of a broken bone looks like, and this is what you want to keep your eye out for. Anything like this is important. It's going to feel, look, and look like a rock, heavy, dense. It'll be in with rocks, but it's not a rock. It's a piece of a fossilized Ice Age bone. All right, if suspected fossils are encountered during construction, the construction workers shall immediately halt construction within 50 feet of any potential fossil find and notify the supervisor, project manager, and project paleontologist, Wayne Thompson, Pacific Paleontology, at 831-535-8545, who shall evaluate its significance. Please take a minute right now, write down that name, write down that phone number. Failure to report suspected fossils is in violation of federal, state, and/or local regulations and is punishable by civil, criminal, felony, and misdemeanor penalties, including fines and/or imprisonment. All right, this has been a presentation by Pacific Paleontology, Wayne Thompson. There's the email down there at the bottom, pacificpaleontology@gmail.com. I'll give you a second to write that down. And please contact me by phone if a discovery is made.